Hello everyone. Good morning or good evening depending on your location. My name is Muruga Angamuthu and I have 23 years of experience across data engineering, AI and ML, cloud technologies, enterprise BI, data science and in the manufacturing sector. It's a pleasure to be here at Conf42 to share insight on the topic AI driven predictive maintenance that transforming the backbone of manufacturing. For decades, factories have relied on two extremes. First one is waiting until the equipment fails and then fix it, which is reactive maintenance, or carrying out scheduled preventive maintenance that often wasting valuable resource. But today we stand at pivotal moment with the power of AI, data and connected systems. We can move beyond reactive firefighting and embrace proactive intelligence maintenance that drives efficiency and resilience. Let's get started. Here is the agenda today. First, critical inflection point in the manufacturing. Second, AI driven maintenance resolution. Third, evolution of maintenance strategies. Fourth, technological architecture enabling transformation. Fifth, advanced AI methodology in industrial environments. 6. Real world success stories. 7. Why 60% of predictive maintenance initiatives fail. 8. Implementation of blueprint for success. 9. Emerging technology and future trends. 10. Actionable roadmap for implementation. 11. Key takeaway. Let's start with industry challenges. Critical inflection point in manufacturing. Let's see why AI based approach is essential. Let's look at the problem and the high cost of reactive maintenance. Manufacturers today are under the pressure and traditional way of maintaining equipment are simply too costly to sustain. Reactive maintenance. When equipment fails without warning, the impact is massive, up to 3 to 10 times more expensive than predictive maintenance. The average loss during unplanned downtime is up to $50,000 per hour. This includes production loss, labor inefficiency, and sometimes even penalties for late shipments. And the market speaks for itself. The AI in maintenance sector is expected to grow from 4 billion to nearly 16 billion by 2028. These numbers highlights why manufacturers cannot afford to stay in reactive maintenance. Moving on to next. AI driven maintenance solution. Let's see what happens when companies embrace AI for maintenance. One, first, industry implement AI maintenance have reported 50% reduction in downtime, which is half the machine offline time compared to before. Second, 32% decrease in overall maintenance cost, which includes parts, labor, and energy savings. Third, perhaps the most impressive is 385% return on investment. These projects don't just play themselves, they multiply value delivered. Fourth, the models provide 8 to 12 days advance warning, which is critical for planning downtime and avoiding production disruptions. This means organizations can plan interventions, order spare parts ahead of time, and prevent crises before they happen. This represents shifting from reactive maintenance to strategic asset management where decisions are data driven. Next, evolution of maintenance strategy. Let's take a step back and look at how maintenance has evolved. First, reactive maintenance. Equipment is fixed only after it breaks, which is leading to emergency fix. Also, it causes unpredictable cost and major production disruption. Second, preventive maintenance. Here, maintenance follows fixed schedule, often replacing parts too early or too late. Here, downtime is reduced, but inefficiency is there and also waste of resource also is there. Third, predictive maintenance is a conditional based maintenance and service the equipment as needed basis. This method minimizes disruption while keeping the cost under control. Fourth, AI-driven predictive excellence. Here, machine learning predicts failure up to 85% accuracy. Also provides 8 to 12 days advance warning and continuous improve over time. Here we are moving from rigid schedule to dynamic and data driven decisions. Moving to the next. Technological architectures enabling transformations. What make this possible? Let's talk about technology stack. Number 1, IoT sensor network. Industrial machines equipped with sensor with capturing real-time data like temperature, vibration, pressure, etc. Each setup generates 1.5 to 2.3 terabyte of daily data and also enables continuous health monitoring. Second, edge computing. On-site processing cuts response time by 75 to 85% and it pre-filters sensor data. It also supports instant alert and rapid decision making for critical equipment conditions. Third, cloud data platform. It is a scalable infrastructure, stores historical data and powers advanced ML training and deployment. It enables predictive model and cross-facility performance benchmarking. Altogether, these layers gives us both speed and intelligence. Moving on to the next. Advanced AI methodology. First, autoencoder based anomaly detection. It learns normal equipment pattern to spot deviations. It achieves 90% accuracy with 31% fewer false alarms. Second, random forecast forest classifier. It classifies and pinpoints specific failure mode. It also delivers 78% precision in the predictive diagnostics. Third, recurrent neural network. It analyzes time series sensor data over a long period. Also, it detects degradation pattern before it failures. Fourth, digital twin simulations. It creates virtual replica of physical equipment. Also, it boosts prediction accuracy by 67% through simulation insights. Each technique has a role depending on the context. Next, let's see the real world success stories. Why 60% of predictive maintenance initiative fails? Of course, not every initiative succeeds. In fact, about 60% of project fails. Let's see why it fails. Number 1, data ingestion complexities. Nearly 80% of deployment struggles with the legacy machine, load IT system and inconsistent data quality. Also, lack of sensor and poor standardization slow down reliable predictive insights. Second, scope and budget management. Projects often exceed budget by 30 to 40% due to underestimated complexity, overly wide scope. Weak proof of concept validation leads to cost overturn and delayed return on investment. Third, organizational resistance. Around 65% of technicians resist adoption because fear in the job loss or not trusting AI recommendations. In inefficient training and weak change management amplify resistance to new system. Predictive maintenance is not just a technology problem, it is also about people and process. Moving to the next. Implementation blueprint for success. First, value first approach. We need to start with the most critical equipment where the failure cost is most, and also focus on high impact wins before wider rollout. Second, strategic data integration. Build a unified data architecture by linking maintenance, production, and quality system. Break down silos to enable seamless predictive insights. Third, human-centered design. It engages technicians early in the process to shape tools and workflows. It creates natural interface that builds trust and adoptions. Fourth, phased scaling. We need to scale step by step with the return on investment validation at each stage and also prevent budget overturn while ensuring measurable business value. When you follow this blueprint, adoption improves significantly. Emerging technology and future trends. Let's see what is next here. First, explainable AI. It uses transparent algorithm that makes predictions human interpretable. It builds trust among technicians and also increase adoption by 47%. Second, system level monitor. It goes beyond single component to capture cascading. It enables entire insight across the interconnected production system. Third, sustainability applications. It AI driven maintenance cuts unnecessarily energy and resource usage. It lowers emission by 500 to 1500 metric tons per facility each year. This is about building a smart, sustainable factories. Actionable roadmap. Here is the practical roadmap. First is foundation. It takes 1 to 3 months time to build a foundation. Access equipment criticality, set baseline metrics and deploy sensor on top assets. Begin data collection and integration to build the foundation for predictive insights. Second, pilot implementations. This process takes 4 to 6 months of time. Apply ML models to highest impact equipment and then train the maintenance team on the new workflows. Track KPIs, validate results, and document early return on investment to build the momentum. Third, expansion. It takes 7 to 12 months of time. Scale deployment to the secondary assets and refine models from the pilot learning. Integrate with ERP production planning and roll out structured change management. Fourth, in the second year, work on the optimization and innovation. Leverage advanced analytics and a digital twin for higher accuracy. Develop custom ML and establish a predictive maintenance center of excellence. Key takeaway. To wrap up, here are the key takeaway. Number one, proven return on investment. AI driven maintenance cut down cost by 50% and also lower cost by 32% and also delivers 385% return on investment in 3 years. Second, strategic implementations. Success comes from starting from high impact equipment, unifying data system and engaging maintenance team early. Third, future proof operations. The next step is moving from isolated predictive tool to fully integrated smart manufacturing ecosystem. Thank you so much for your time. I'm happy to take any questions. Bye. See you later.